Good afternoon, ladies and gentlemen. So today we have one interesting topic with us, that is logarithmic and exponential functions. So the first thing that we need to know about logarithmic and exponential functions is the three basic rules. So we know that the first rule that we can have is x m multiplied by xn, where you were taught to say that in indices, when the bases are the same under multiplication, you basically add the powers. Then the second rule that you basically have is x to the power n divided by x to the power n, where this is the same as x to the power n minus n, because the bases are the same, so you subtract the powers. Then the third rule that you may have is x to the power m to the power n. When you multiply these, you get the value to be mn. So the other thing that we can add on to be our rule number 4 is just under fraction indices, where we know that x to the power n over m, this is the same as m to be the root of x to the power n, like this. So let us use these equations, the one we have called the rules, to basically handle real life questions like finding the value of 100 to the power 3 over 2. So what you basically do here is this 2 goes in the root and 100 comes there to the power 3. So what is the second root of 100, or the square root of 100, to be? It is 10. Then we know that 10 to the power 3 is basically 1000. We have the other one, which is 32 to the power negative 2 over 5. So for you to basically remove this negative, you will say 1 over 32 2 to the power 2 over 5 to be equal to, then this will become 1 over the fifth root of 32 to the power 2. And we know for sure that the fifth root of 32 is basically 2, and 2 to the power 2 is basically 1 over 4. So this is how basically you solve such kind of questions. So using the rules of indices, we are given a question to say, show that 3 to the power 2x minus 1 is equal to 9x over 3. So for you to basically show that this side is equal to the other side, we need to use the rules of logarithm. Remember, under division, you said that if the bases are the same, you can subtract the powers. So here the bases were the same, that's why they had subtracted the powers. So in short, we can say that this was this in its correct context at first. So from here, now that we do that, we can say this division sign goes to multiplication, and if it goes to multiplication, then you can have multiplied by 1 over 3, where this times that is basically 3 to the power 2x divided by 3, where we can use the third rule that we had here, where they separated the powers. So we can also separate the powers here, and you will have 3 to the power 2x divided by 3, and this will be equal to 9x divided by 3. So we have shown that this side is basically equal to the other side. So this is how basically you solve such kind of questions. So adding on to what we have, we can just have a simple task. So find the value. So what you can do, you can pause this video to check if you have truly understood what we are trying to put across. So we have these questions: a to the power 0, b 4 to the power negative 2. So we know that any number to the power 0 is basically 1, and this is also the same as 1 over 4 to the power 2, which is the same as 1 over 16. So we are just finding the value. So the other thing that we can love to show is basically, so show that 16 to the power x is the same as 4 to the power 2x. So what you can do here, you can even break down this 16. 16 is the same as 4 to the power 2, where we can multiply these two and we get 4 to the power 2x. We have shown that this side is equal to the other side. Or if you want, you can also show that this side is equal to this side by doing the reverse format, where you break down this by saying you separate the powers, and we know that 4 to the power 2 is basically 16x. So whichever method you want to use, you will basically find the answer. So in addition to what we have, let us look at what I referred to as exponential equations. So under exponential equations, I believe you had these in your YA classes, your level grades. So I remember in your grade 12 examinations, you were given things like find the value of x given 3 to the power x being equal to 81. So we know for sure that for you to basically find the value of this x, you will make sure that the bases are the same, and you have 3x to be equal to 3 to the power 4. Then you cancel these 3, and you have x being equal to 4. So this is how basically we used to solve such kind of questions when we were in grade 12. But now we move a step forward. How do we apply such kind of concept and the rules of indices for us to solve what are referred to as exponential equations? So under exponential equations, let us say we have 2 to the power x plus 2, 1 minus x to be equal to 3. So what we basically do now is, how do we basically solve this kind of an equation using exponential equations and the rules of indices? So like we said earlier, we can break this one down. Remember, if this is negative, which means the original was basically division. So meaning it was 2 to the power 1 divided by 2 to the power x being equal to 3. Then no matter what kind of math you apply here, you cannot solve this unless under special conditions. But for today's lesson, we will basically focus on the exponential equations. So if you look at the exponential equations, you will always find something to be fishy. So in this case, the 2x is fishy. So you can say let 2x be any letter of your choice. I can even put g. So meaning where there is 2x in this case, I am replacing it with g to be equal to 3. Then from here, we know that if you have a division sign, you basically take it to multiplication, and you have something to be of that kind. Then immediately now we do this. We can distribute this g to both sides. And if you distribute g to both sides, you will have g squared plus 2 to be equal to 3g. I believe you did your fractions. You can even use fractions method here. So from here, we'll just bring the equation here. So we can take this 3g to the other side. It becomes a negative 3g plus 2 to be equal to 0. Then remember, I taught you how to use to solve quadratic functions. So we can find the product, sum, and factor now. So the product in this case is 2, the sum is negative 3, and the two numbers are negative 2, negative 1. So get these numbers and put them here. So you have g squared minus 2g minus g plus 2 to be equal to 0. Remember, I said you can replace these on here in any order you wish. So you have g minus 2 minus g minus 2 to be equal to 0. So you have g minus 1 and g minus 2 to be equal to 0. So g is equal to 1 and g is basically equal to 2. Immediately you do this, you were not told to find g, you were told to find x. So meaning you will say 2x to be equal to g. In this case, g has become what? 2. So applying the rules of exponential, applying this kind of rule here on this particular question, you know that here there is power 1. So this and that will basically go, and x is equal to 1. So we have solved for 2. So we now solve again for this one, and you know that any number to the power 0 is basically 1. So 2 to the power x is equal to 2 to the power 0. And this under mathematics, we know that we can just cancel, and you have x to be equal to 0. So this is how basically you use exponential equations for you to solve such kind of math. So we continue. So under our continuing here, so we can attach some questions which we can love to solve. So let us solve these particular equations. So we have solve a 2 to the power x being equal to 64. So if you have truly understood, you can pause this video and attempt. So let's solve together. So this is the same as 2 to the power x, where the bases need to be the same, and this is the same as 2 to the power 6. So that when you multiply 2 6 times, basically gives you 64, where these 2 can cancel and x is equal to 6. The other one we can have is 5x to be equal to 125. We know that 125 is the same as 5 to the power 3. It is now not the bases. We are still finding the powers, so we just cancel these, and x here is equal to 3. We can have a little bit complicated equation, which is 4 to the power x being equal to 0.5. So how do you basically solve this? So here we can break this one down, and you have this to be 5 over, remember, this here can also be 5 over 10. So using now what we have learned, or rather what we have from learning, we know that somewhere here the bases need to be the same, and you have 4x to be equal to 1 over 2, where this under the negative rule of indices, you have it to be 4x to the power 2 to the power negative 1, where this here is the same as 2 to the power 2 x to be equal to 2 to the power negative 1, where this is the same as 2 to the power 2x being equal to 2 to the power negative 1, where these 2 can cancel and 2x is equal to negative 1, where now we divide both sides by 2, and you have the value to be negative 1 over 2. So this is how basically you find the equations. So with us, we can continue a bit by trying to look at the other side, where we look at the conversion of logarithms to exponential functions. So let us now look at logs. So we know that this log is a special log that has a log of base 10. So in here we are trying now to change logarithms to exponential and vice versa. How do you basically do this? So we know that log x 10, is equal to 4. So if we were to change this logarithm to exponential, the base of the log becomes the base of this number, and this basic number here becomes the exponent. So we have 10 to be equal to x to the power 4. So this is what we basically have for us. So we have converted from log to exponential. Then the other one we can have is log 3 x to be equal to 5. So what you can do best is pause the video, try to see if basically you have understood the conversion of log to exponential. So we continue. The log, the base of the log will come here, and this number will basically become the power. So you have x to the power 3 5x like this. So we have converted logarithms to exponential. So now we can have another beautiful example where we look at the conversion of exponential to logarithms. So for us now to basically do this, we can have 3 to the power 2 to be equal to 9, where we know for the fact that this 3 was the 3 that from the log. So we will say log, so this 3, which is the base of this number 2 here, so this 3 will also become the base of this log. Then this 9 comes here, then the 2 drops down. So this is how basically you change from exponential to logarithms. So you can have x to the power 3 to be equal to 10. So for you to convert exponential to logarithm, you make sure to say if this is the base of this number, the same x will become the base on the log, and this 10 basically here will come there, then the 3 joins there. So having truly understood the conversion of logarithm to exponential and exponential to logarithm, I want us together to solve these particular questions. So we are told to find the value of a logarithm of 2, let's say x is equal to log 2 64. So there are basically a lot of rules we can use, but for now we are going step by step. I believe, yes, in here we have great mathematicians who would love to simplify our work. So for now, let's stick to porridge. So we know for sure that this can also become 2 to the power x being equal to being equal to 64. We are now dealing with the conversion of logarithm to exponential. Then immediately we do that, we know that this can also become like the equations that we are from solving above, and this will also become as 2 to the power 6, where these two can cancel and x is equal to 6. So this is how basically you solve this. You remember the work that we are from having on top? Yeah. Then B, let's say we have log x 25 to be equal to 2. So we can convert the logarithm to exponential by saying 25 is equal to x squared. So we know that 25 can also be broken down to be 5 to the power 2, where if now the powers are the same, you can basically cancel them and the bases are the ones which will be equal, and in that case the value of x is basically 5. So looking at what we have looked, we can now go to some special kind of logarithms. So under here, we will just write the rules of logarithm, where we need to understand for sure that if we are applying the rules of logarithms, I will show you how they were derived, but there is no need to know how they were derived. So basically, let's have p to be equal to a to the power m, where if you were to change this to be in logarithmic form, you will have log a p to be equal to m. This is what you have. So let us have q to be equal to a n. So if you were to change this again in logarithmic form, you can have log a q to be equal to n. So what am I trying to put across? We know for sure that under the rules of indices in our preamble, we had said that a to the power m multiplied by a to the power n, the answer here was a m plus n. So what we are putting across is basically, remember the values of m in this case. The value of m is this, which is log ap, and the value of n. So in short, what we are trying to put across here is, let's assume that we have p and q here. Remember, p and q meaning we are dealing with them under multiplication. So if they are under multiplication, then this and that will come. We are just replacing on p, where we have this multiplied by an. So these two are the same, and we can have this to be equal to that. So if these two are truly the same, what are we trying to put across here? What we are trying to put across here is us now trying to remove where there is m. We say a to be log ap, plus where there is n we remove, we say log q. So this is equal to am times an. So this is what we basically have, and you know that basically this side is the same as that side, so this is also the same as am plus n to be equal to a log ap plus log aq, where this and that can go, and m plus n is equal to log ap plus log aq. So what we're trying to put across now is that the multiplication of logarithmic expressions, that is pq, is the same as the addition of two basic logarithmic functions. Then the other one that we can basically have here is, let's say you have log ap over q. So I've shown you how to derive that of multiplication. We'll just go directly to do that of division, and you have it to be log ap minus log aq. So this is that of division and multiplication. So we'll create another video where we'll continue from where we have ended to basically share the knowledge with the world so that we grow as a big family. Your host, Golden Zudo.